Hey, what's going on, everybody? Welcome back to Civil Engineering Academy. My name's Cody. Let's go ahead and get started. All right, so today we have an FE type of problem. This is going to be out of the FE manual. Here's what the question says. Derive a relationship for the applied force F, the drum radius R, and the drum torque tau. That's what that symbol is. It's tau. Using the simple band brake shown below. The brake rotates counterclockwise and the coefficient of static friction is 0.4. All right, so it gives us a lot of hints towards this problem. We see our four options available to us in units of or unknowns of tau, F, which is our applied force, and R, which is the radius of our drum. So so I guess to get started here, the FE reference handbook, that's what we're going to be looking in. So let's go ahead and write that out here. We're going to be looking in version 10.2. It's the latest and greatest at this point in time, at the time of this video. We're going to be looking on page 110. And in fact, it's actually going to be a belt friction problem. The reason why is because it almost gives it to us in the problem. We have a sort of belt and a drum. So we need to understand that relationship there, and that's going to be a belt friction problem. So that's going to be in the static section and belt friction. All right, so with that said, let's go ahead and write down our formula that we find. F1 is equal to F2. We need to multiply that by the E, and then we're going to raise that E to the mu. That's what that guy is, and then we have a theta there. All right, so let's go ahead and address some of these unknowns. F1, it says it in the manual, F1 is force applied in the direction of the impending motion. So that's going to be the force that's about to happen, right? We're wanting to slow this drum down, and so we're going to apply this force to really slow it down and sort of prevent it from rotating in the counterclockwise direction. So you can go ahead and identify that this guy is rotating this way, right? It's kind of given to us there counterclockwise. So the resisting force that we're about to apply is there. So this right here is going to be F1. Okay. F2 is the force applied to resist the impending motion. So basically the way it was going before, well, that's going to be this guy. So this belt has two different forces. You've got a force that's being applied this way and a force that's being applied this way. Okay, so that's that. Mu is going to be the coefficient of static friction that's given to us in the problem. That's 0.4. And then theta is going to be the angle of contact between the surfaces. And keep in mind, it has to be in radians. Okay, you can't use degrees for this formula. We need to put it in radians, but super easy to do. I'll explain that when the time comes. So let's go ahead and kind of plug and chug into our formula real quick. We don't know F1. We don't know F2. We know the E. We can plug that into our calculator. Mu, that's given to us in the problem. That's 0.4. And then we're going to multiply that by the theta. All right, so let's think for a second. 360 degrees is actually 2 pi. Okay, so that's something you need to keep in the back of your head. 360 degrees is 2 pi. So the angle of contact, if we have a force that does something like this and a force that does something like that, bad drawing, but it's actually only touching halfway through. Again, really bad drawing, but it's actually only touching half the circle. If we were to kind of come up here, doing something like that. So what is 1/2 of 2 pi? That's going to be pi. Okay, so that's what we need to put there. That's the angle of contact between the belts and the drum. All right, so let's go ahead and solve this guy out. We end up looking a little bit like this. You end up with something that looks like F1 is equal to F2 times 3.514. All right, and so this is actually equal to, if we want to make it more proper, 3.514 F2. Okay, so now we can plug that in later down the road whenever we need it. We've got it in our toolbox. Let's go ahead and add it into our toolkit and use it later. So next step is we need to sort of figure out a relationship between that F, that applied force, and something to where we can plug it in and work our way through this problem. Well, we can actually take a moment at the fulcrum and it will get rid of that F1 force, and we can find a relationship between the applied force, F, and the F2 there, that force applied to resist the impending motion. Okay, so that's what we can do. Let's go ahead and do that real quick. We're going to take the moment about the fulcrum, okay, and we need to go ahead and establish what's positive. I always like to use my right hand rule. If you're writing with your right hand, it will naturally curl in the counterclockwise direction. So that's kind of how I remember what's a positive moment, what's not. You can flip it, just whatever you want to think about it, however you want to think about it. This equals 0, okay? And then when we do this, F1 it actually acts in the line of motion, in the line of the moment, so that doesn't contribute to the moment. F2 is a perpendicular distance of 10 inches away. I'm just going to write 10 F2. Okay, that's a positive moment because it goes with our right-hand rule, that established positive that we said earlier. Applied F, the applied force F, also acts in the positive direction. So this is going to be another positive moment. We're going to have 15 be our perpendicular distance from where we are taking the moment. Our applied force is F. Right, so now we have sort of this relationship. We can go ahead and move the 15F over to the other side and solve for F2 to use in our toolbox again later. When we do that, F2 looks a little bit like this. You're going to have a negative 1.5 F. All right, so what I did is I moved that 15F over to the other side, divided by 10. That's how you get that formula there. All right, so now we have F, so we can use that, but we still need R. We still need to solve for something with R, and the way that we can do that is solve for the torque in that drum. And if you don't know what torque is, it's basically a moment almost. So we have this sort of circle, we have that drum, we have a force being applied here, that's F1, okay? And then we have this other force right here, that's F2. And then we have a center of our drum. So if we take the moment about the center, let's go ahead and do that. Do this real quick. Moment about the center. We're going to go ahead and establish that this is positive again, just to keep it consistent. This is equal to the torque, which is that little squiggly T almost. It's tau. And that's going to be equal to, go ahead and take the moment at the center. Well, remember, the distance from the center to the outside of a circle is, you learned that in 3rd grade, that's R, right? So, and same with the other side too, that's R as well. 2R equals diameter, all right? So this guy, let's see, R is the perpendicular distance. The perpendicular force is F2. That's going to be a positive moment because it goes with our applied positive. And then we have that F1 actually acting against what we established to be positive. So that's a negative moment there. So we have minus R times F1. So there's that, and then the next step, well, looky here, we have something that we can use in our toolbox. We can use this formula right here and plug it in there. All right, so let's go ahead and do that. We're going to have RF2, here you can see where we're going here, RF2 minus R times 3.514 F2. So now we're starting to see some familiar territory here on what we can use, and we're going to go ahead and simplify this out. You end up with something that looks a little bit like this. It looks like negative 2.514. That's that's RF2. Keep in mind that's our tau, right? So something else here, well, that's not really our answer, right? That's not really our answer. We need to plug in what we established to be F2. And hey, while I've got you here, if you've already enrolled in one of the review courses at civilengineeringacademy.com, keep it up. You can do this. If you haven't, I encourage you to go to civilengineeringacademy.com to check out some awesome practice exams and resources that'll help you pass your FE and PE exams the first time. With that said, this F2, we're going to have some crisscrossy lines here, but we can plug that in right there. All right, so let's go ahead and do that real quick. This ends up being negative 2.514 R times, it's an R right there, times minus 1.5. You can kind of see where we're going here, times F, and this ends up looking an awful lot like 3.77 FR. This is going to be C. All right, so a long-winded problem. Hope this clears some things up. Hope it helps. We'll catch you next time.